Okay, we are in chapter 4, and this is the chapter about the whole list thing. Remember, list is kind of like a string, but we can have different data types in there. Okay? Actually, what was the very last thing we talked about? We talked about. Let's go to the end here. We talked about the count. We did the sort and all that, didn't we? Yeah, we did all this. Yeah, because we appended, we popped, and all that stuff. So we removed something. So it's I was actually grading some Java work this morning, and you know how we use the double equal signs to check if it's equal, but in Java it's the dot equals. In PHP it's actually a triple equals. You can use a triple equals. It'll handle both strings and objects. So it's like every language is different. So it's just different. All right. So let me start up Mr. Magical Python here so we can use him. All right. So we talked about appending. Remember, appending adds something to it. Pop removes it. Count counts it. Remove removes it. It's pretty self-explanatory. Now let's cover split. Okay, let me get this somewhat smaller so I can get it all on the same screen so you can see it. Okay, I'm going to just type in again what he has here. We'll talk about it. Minnesota Vikings. Okay. If I do a.split, again, I recommend you walking through this. That way you can see that it works. And you see it actually created me a list, and it split Minnesota and Vikings. It's split by what they call a token. They don't mention that in the book, but really the space is considered a token. Okay. There's actually some problems with that. How can I say this? Okay, I have a student, Darren. Darren's not in this class, is he? Well, his name is like Darren Van something. Whatever his name is. So if I was using names like Cameron Tillman, and I use split, Cameron would become the first part, Tillman would become the second part. But what if I did that with Darren? I would now have Darren would be the first part, Van would end up being his last name, then the second part is last. So you see you can have issues using it. So you just got to be careful on that stuff. Way back when I wrote a program to scan in email addresses from this customer of mine would buy email addresses in books. Our program would scan them in, OCR them, and then convert them into the computer. And I had the same kind of issue. You had to handle different type of punctuation and spacing, and it was funny because this is years ago, but I also had where people could sign up for a mailing list. You know how you can sign up for a mailing list at places? Well, when you ask people your email address, most people would say, kdewey@rose.edu or something. But it never failed. You would always have the person who would just say kdewey. You know why? Because if they were on AOL, that's what their email address is. It's strictly just their name. So I actually had to build it into my program that if they submitted something without the @domain, add AOL to it. It was weird. But it's so working with split, you got to be careful on what your data is. Okay. Because if you have a 3-part name, it's going to have 3 elements, and it might not be what you're looking for. Okay. Let's run it again. This time we're going to do a.split. But this time we're going to split on the I character. So what it did is it went through the string, and rather than splitting on the token of the space, it used the token of the I. So that's why the M in soda, is split on the I. Then with the Vikings, we ended up with a V, and then the KI. And you'll notice we actually have an element here that is N soda space V. So what we did is we changed the token or the item that the split works with. So you can actually, very easily tell it. I mean, if you just say split, it's going to do spaces. But you can specify other stuff. Okay? And here they also have a dot split. This time we're specifying the double N. And we're going to split just on the ends. So it'll be MI. Then the split token is NN. So then we end up with a soda space Vikings. Okay? Everybody okay on split? It's pretty self-explanatory. Nothing spectacular there. This stuff is healthy. Not healthy. Handy. It is healthy too, I guess. And, someone asked me a couple years ago, like, but why do you cover all this stuff if we're never going to use it? Well, it's just like anything in education. Majority of the stuff you're never going to use. But at least you've heard of it, so that 5 years down the road when you want to do something, wait a minute, I remember something, at least you can engage your search algorithm and find it. At least have an idea of how you did it. It just makes it easier. So, all right, so let's continue on. All right. So, all right, we talked about that. He's got some examples there. We're not walking through all those exercises. Okay, simple dispersion now. Okay, let's make a list. A new list here. A list. Okay, equals. We're going to do 20, 32. It matters what order, so put them in the right order. I'm going to get rid of the space. 32, 21, 26, 33, 22, 18. Okay, I just typed in exactly what he had, even though you can't quite see it on the screen. Okay, so we just made a list of numbers, and if I type a list all by itself, you'll see I get the list back. Okay, nothing special. Okay, now I could do this. Again, I could very easily return a single item in the list. I mean, it's just stuff we learned last time. Okay, nothing special there. But there's some capabilities a list bring to us, and one of them is max. If I type forgot the parentheses. So if I type max a list, it's going to go through my entire list and return the maximum value. Okay. Okay, pretty easy to do, especially when working with statistical type stuff. Okay, a lot of times when I give extra credit, if I ever decide to do it, what I'll do is I'll take the highest grade. Say, I'm real big on, if I give extra credit, everybody gets it. It's not like, it's Craig, isn't it? Chris. I was close, I had to see. See, like if Chris came to me and asked for extra credit, would it be fair to me give Chris extra credit but no one else? Chris will be happy for that, but it's not really fair. So what I would do is I would offer the extra credit to everybody. So sometimes what I'll do is I'll look at your grades and say, okay, so if I'm giving extra credit, I will take Cameron's grade, which would be the highest, probably. One of the highest.
Well, he's not in this class, so I could
well, that I would give him 100.
I would say Chelsea's grade.
Well, okay, Chelsea. There you go. But I would take that person's grade. I do it a lot in like computer security and stuff like that. But this semester is a little different. What I'll do is I'll take the highest grade, raise it up to 100, and figure out how much I raised it by. Then give everybody the same percentage or the same number. So, if Chelsea, her highest grade was a 90. So I brought her up to 100, so she got 10 points, so everybody gets 10 points. That way it's fair for everybody. It shouldn't be for, well, Chelsea, you already got 100, so you get nothing, even though you worked hard. But Chris over here was a slacker and ended up with a 40, so I'm going to give him, no, that's not fair. So there are times when you might want to use something like max. You can also use min. And when looking at stuff like this, I get a lot of people who find it hard to visualize. Like, why would you want to use something like max when I can just look at the list and tell you? Well, great. This list has a whole, 1, 2, 3, 4, 5. It has 7 items in it. But yes.
How do you do an average?
We're getting there in a minute. We're getting there. Okay. So, but a lot of people don't realize it. Yeah, we got a list of 7 right here on the screen. But what if it was a list of 70,000 or 7 million or something? Like in computer security, they had to calculate the index of coincidence off of thousands and thousands of letters. So, in forensics, they had to find a particular image out of 4,000 images. So that's why you learn how to do this, to automate the process. Okay. We can also use it in calculations. Like they have here, they actually have max of house. What they're doing is they're actually looking for the letter that has the highest value. What they just convert it to ASCII is what they do. They get that. Remember, we use ORD to get the ASCII value. That's all they're doing. Convert it to an ASCII value, figure out which letter has the highest value, and then returning that. You can also find the minimum of the house. Well, not main. Min of house. Anybody ever watch House?
Yes,
It's over now, isn't it?
I think so.
I love that show.
It's a great show.
It was awesome. I read an article by him once. I forget the main character's name. But he said he was in that TV series long enough that if he had actually gone to school that entire time, he would actually be qualified to do the job that he was doing in TV. Which he didn't have a clue about. So it was kind of interesting. He has a massive British accent. But in the show he doesn't. Okay. So we can also use it for calculations. Okay, what's happening here is we're getting max, which is 33. Then we're getting min, which is 18. So we're going 33 minus 18, so we're using it for math. So, pretty easy. So what if I wanted to take that list of numbers right there at the top of my screen, and I wanted to, we'll say that the assignment was worth 50. So how much would I have to give somebody as extra credit? Like I said, I would take the highest grade, bring it up to the 100, or in this case 50. So how could I do it where it tell me exactly how much to give everybody? So if the maximum grade was 50, how could I write something which would tell me how much I'm going to give Chelsea if she got to 33? Idea?
Am I allowed to answer it?
Yeah, go ahead.
Okay, 50 minus max A list.
Perfect. 50 minus max A list. It's going to take 50, which is obviously the highest number, and subtract the max. So in this case, I would give her 17, then everybody would get 17. I actually took a general physical science class. Anyone ever had that class yet? Well, it was years and years and years and years ago, and the teacher did not teach out of the book whatsoever. All he did was cool stuff, which was kind of fun. Brought lasers into class and stuff. But it's funny because came time for the test, and the test was 100% out of the book. It was the test bank test. So we sucked at it. I get an 11 out of 100. And I'm like, oh, crap. So he comes in and goes, all right, high score is 11. That's 100. I'm like, sweet, I get 100. But I was like, man, I feel...
So yours was the highest score?
Yeah, it was a high scoring test.
Wow.
It was, well, I mean, like I said, all we did was, I mean, none of us were science majors in that class. So he just did cool. Literally every day he'd bring in something else cool to do, but the test was literally straight out of the textbook that we never opened. So I was like, okay. So, but it was, yeah, it was different. So that's how we could determine how much curve we would add to the test for everybody. Okay. In the past, I have sometimes curved it above 100, but then I would also give Chelsea, I say if I curved it by 20. So then, Chelsea would end up getting 100 or 53 in this case. She would get the 3 extra points as well. So I like to be fair like that. I just don't believe in, no, it's not fair the other way. So it's not even how I grade. Doesn't mean I'm giving extra credit in this class. Just saying. Because, by the way, Cameron's already got 100 on everything. So,
Go.
So if I give a curve, it's going to be 0 at the moment. And someone actually came into my office and said, well, that's because Cameron works in your office. Trust me, I don't write this stuff for him. He writes it on his own, and trust me, if you look at his work and my work, it's night and day. But his works, it's like, dude, where'd you come up with that? It's crazy. Okay, so let's continue on. Okay. Now, in the last 2 programs, I've had you define functions, methods, or something. Let's look at what he does. First of all, is that a function or a method? Okay, we got one of each.
Because it's returning a value.
It's returning a value, it's a function. Plus it says the word function right underneath it. Let's go ahead and type that in real quick.
I didn't see. I get part of it.
Defined GetRange A list. Make sure you put. I screwed it up. This darn parentheses is killing me. Okay, make sure you put your semicolon at the end. Minus min. Okay. Haven't hit enter yet. Okay, so what we're doing is we are defining a method called GetRange that will receive one argument, which is the object A list. And I missed a parenthesis right there. Very long function, has one line in it after the definition. The line basis is return the max minus the min. Okay? So we're returning the range. Okay? Alright. So now, here, they type in get range of 2, 4. So in other words, we're going to call the function get range. We're going to pass it the list 2, 4, and it's going to tell us the range is 2, 4, or is 2. I'm sorry. Okay. So far, so good. Can I do? I don't know if I can do this. Yes, I can. I can also type get range A list, because remember we were working with A list before. So I can actually pass it the list we were working on up here somewhere. There it is. There's A list. So we're passing an A list. So it received that list, got the max and the min, subtracted them, and got the range. Okay. So, this method does one thing. Has one line that subtracts the 2. Wouldn't it have been easier just to type in max minus min? It would have. But there's a lot of times it's better to have a method. That way you don't have to remember. You don't have to remember, okay, now what was the syntax to get the maximum value and the minimum value? First of all, even what is range? So this, an easy way, even though it's a short method, it's a handy one. Okay? Alright. And there's actually our original list right there. So we could pass it the regular list. Okay? So far so good. So we saw how we could create a function to do that. Anyone installing iOS 8 right now? It's released. I'm already downloading it right now. Get out of class, I'll have it. I can't believe you guys. Everybody getting the phone Friday though, correct? They updated my delivery date, by the way. Now my delivery date is the 2nd to the 13th of October. Well, in other words, Friday morning I'm getting it anyway. So it's still good. So. All right. Now he has a method. I'm sorry, another function. Okay, to return the maximum value in a list. Okay. All right. Let's talk. Well, should I type this one in? Yeah, let's type this one in so we can see exactly what it does. Doesn't help. Or doesn't hurt to have more examples. GetMax A list. So the first line there is really just defining the function called GetMax. It's going to receive an argument called A-list. Okay. Now inside there, we're going to take max so far is equal to A-list 0. That basically says we're starting off right away and saying, okay, we're receiving a list. So the maximum value so far is obviously the first item in the list. Makes sense. Okay. But then we're going to make a for loop for position in range 1 minus the length of the list. Okay. I'll move this over so you can see it. Right there. I don't know what you... Actually, let me move this page a little. Put this at the bottom. Put my program at the top. That works better. Okay. So now we're saying, okay, for position, which is going to be the thing we're going to use to loop with, range. Now we're specifying 2 items this time. We're specifying a 1 and the length of a list. Remember, if we specify 1 item, it's the ending value. If we specify 1 comma, that's the starting and the ending value. Okay? All right. So we know lists work with indexes, just like strings did. So why are we starting with 1 and not 0? Does anybody know? Remember, strings start with 0, so do lists. They start with 0. So why are we starting with 1? Exactly. We've already specified it. We've already said the max is already 0. So why loop starting at 0? Because we've already said the max so far is 0. So now we're actually going to loop starting at position 1. We actually could have modified this to not have max so far is equal to the first, and we could have just modified our loop, but we're going to do it this way. So if a list position, which is going to be 1, 2, 3 so far, is greater than max so far. And we're saying, okay, if the next one, which is position 1, is greater than the variable max so far, then max so far is equal to a list POS, or piece of position. So that's it. All right, everybody understand what that's doing? Leroy, do you understand what we're doing? Maybe a little.
Well, I'm there.
Okay.
1 foot in, 1 foot out.
Okay.
Following.
All right. So let me go through this one more time. So GetMax receives a list. So I'm going to pass it a list. And I say, okay, if I got a list of 100 items, to start off with, the biggest one is the first one so far. We set it to that. Then I'm going to go through the list starting in position 2, which is actually index 1. Starting in position 2 to the end of the list. And I know it's the end because I'm using the length method. Then for each item, if that current item is bigger than what we've already saved, then overwrite the bigger with it. It's kind of like if I went here and said, okay, everybody, I'm going to find who has the highest grade in the class. So I said, Chelsea, what's your grade? And she gave me her grade. Okay. Everyone ever watch Hell's Kitchen?
Yes, I'm like,
Okay. Well, every time he does the who has the best meal, like, okay, obviously the first one to go is the best meal. So they sit on the throne of wonderful meals. Then they bring up the next meal, and he judges it. Okay, is this meal better than the first meal? If it is, you replace the person on the chair. If not, he says you're an idiot, and he tells you to sit down. And you keep going, and obviously you end up with the best meal sitting in the chair. It's the same thing we're doing here. We're going through each item in the list. The if statement says if the current item is bigger than the variable max so far, then replace max so far with the current item. In other words, you had the better meal, put you up on the chair. Okay? All right. Oh, darn it. I messed up. I forgot my return statement. So how can I go back and add my return statement? Anybody know?
sure.
I gotta put it up here? Oh, just hit enter. Very nice. So push my cursor somewhere on my statement up here and just hit enter. Now, if I put the return statement right here, will that be correct?
No.
It's not correct, because it'll actually, what will happen is, if the current item is greater than the max item, we'll reset the max and then return, be done. That's not what we want. We want to go through the whole list. So we need to backspace to here. So would that be the correct position to put it? Not either. We really need to backspace all the way to there. So because we want to loop through the entire list, checking every item, then we want to return. Return max so far. Then hit enter twice. Okay. Python is real big on this whole indenting thing. Yes.
How'd you get that? Can you explain again how you got from your prompt back up to your...
Okay, I will show you. I'm going to click up in here. I'm going to just hit enter, and it brings my code down. Okay. Well, at the end of my if statement here, say I wanted another line. If I want to back up, you just hit the backspace key, and it goes, all the way through. Okay.
Oh, okay.
Yeah. So the whole indenting is very big with Python. That's how it manages it. Other languages like Java, it uses the squiggly braces. Okay. So now we have our method. Let's try it. I'm going to call GetMax, and I'm going to pass it a list. Remember, we have a list defined already. It's going to tell me 33. Okay. Is that a, what can I say, not economical? Is that the best way to do it? Okay. So, they're talking about it a little bit here in a minute, but actually talked about it already, but so if I had a list of students and I want to go through this room, figure out who has the highest grade. That would probably be the best way to do it. I'd check the first student and the second student all the way through the whole classroom. But is that a good way of doing it? Is that an efficient way of doing it? Not really. Does anyone know what a more efficient way of doing it would be? Sort it first. Sorting, we already talked about sorting a little. And that would be actually more efficient. Because what we're doing here is we're going sequentially through the whole list. And that's not a good thing. You could just imagine if the list was huge. That would suck. So, all right. So let's we're going to talk more about that too. All right. So we have that. All right. He modifies it here a little bit. So let's modify ours to look like his. Okay. Again, let me change it here. Keep losing my cursor. There we go. All right, let's talk about what's different now. I'm going to bring it down by just clicking up in there. Now, at the beginning it starts the same, but a for loop is changing. Okay? I'm going to comment this for loop out. I'm going to put in a new one. We're going to talk about the differences. For item in a list 1 colon. Okay. And then we're going to say, okay, on that statement so far, on the for loop, just the for loop, the for statement there. So initially we had for POS or for position in range 1, the end of the list. Okay. Now we've changed it for item in a list 1. The difference is now we're basically doing the same thing. We're going through a list, starting at the first position, going, index 1 through the end of the list. Okay, so going through the whole thing, for each item, just assign it to item. It actually is easier because when we write our if statement, if item is greater than max so far, see, I don't have to specify a list.pos. It just makes it easier. Okay, you see the difference in the lines right there? Let me comment this one out, since we're no longer going to use that one. Alright, now we're going to go over here and max, so equals item. And we're going to comment this guy out. I just want you to be able to see the difference. Okay. So our lines are very similar. They all work perfectly. Okay. But rather than having to specify the list name and the position, we're just specifying item. It's pretty easy. Okay. All right, let's see if it works. Okay, I'm going to call GetMax. We're going to pass it our old A list again because we have one. So it still works. So which way do you prefer doing it? The way I'm currently doing it or the way that was commented out? Does it matter? It really doesn't matter. It's just whatever you're comfortable with. Okay. I will tell you that the way it is right now is more common. You'll see it written that way more often. Because you don't have to worry about the syntax of, A-list, square bracket POS and all that stuff. So it's just easier. So you'll see it written the way it is right now rather than the commented out way. Okay? Alright. I want to call this again. But this time I'm going to send it a new list. 3, 6, 3, 8, 9, 12, 1, 45, 65, and 4. Oh, forgot my darn parenthesis again. Don't I always do that? Okay. So it'll work with any list. It basically took my list. First thing it did was it said 3 is the maximum so far. Then it went through my list item by item. It looked at the 6. 6 is bigger than 3. So it replaced max so far with 6. Okay. So max so far is now 6. So it went to the next item. 3. Is 3 greater than max so far? No. Okay. Actually, you know what? I want to modify this so it'll output on the screen every time it replaces it. You know what I mean? I'll do it. So I'm gonna say if the item is larger, I'm gonna get rid of the old way of doing it. Okay? Just so my code's shorter. Well, hold on. I gotta bring it down here again. Okay, I'm gonna get rid of all the commented out sections. I'm gonna show you what I'm talking about. I want to know every time max so far is replaced, I want to know it. So what I'm going to do is I'm going to go right here and I'm going to say print, say new max so far. Let me move it over so you can see it. Okay? I don't need the quotes. There it is. Alright. So what I'm telling you now is, if the next item is greater than max so far, then replace max so far, and then tell me, now we have a new max. Okay? Because a lot of times I like to know, especially when you guys send me problems that can't get to work, I'll always add a few extra print statements so I can see exactly what it's doing. So I want to pass it my list again. Okay. What it should say new max 6. Then should it tell me 3 is the new max? No. So it should say new max 6, the new max 8, the new max 9, new max 12, the new max 45, then 65. Y'all agree? So it should do. Let's see. Darn it. How do I fix that? Does anybody remember how to fix that? What? Turn it into a string. It tells me right there. You cannot convert integer. So I need to bring my stupid method down here for the 15th time. And remember this over here? Not int. I need to tell it this is a string. Okay? Let me make it a little bit wider so you can see it. So I just said max so far is now a string. And I'm going to call it again. Okay? Now let's see if it works. Yay! It did it. See what happened? So did it work correctly? Yes. Worked perfectly. Okay? Now if I move the order of items, so I'm going to bring this down again. This time I'm going to move the 65 way up here in the front. I'm going to make this an 8. There's space there, so it looks the same. So now it's going to output less, because what happens is we already had 3. So it found 6. 6 is bigger than 3. It outputs 6. Then 3 is still not bigger. Then it found the 65, and then it basically says, oh, nothing else is bigger. So you can see by moving the 65 to the front, it's more efficient. It didn't have to make as many swaps. This is actually very similar to the selection sort, which I don't know if they're going to cover in here, but they don't in this chapter. So far so good, everybody with me? Kind of, you got an idea of what's going on, I hope? Yes, no, maybe,
Yes.
hopefully? Okay, good. All right, just trying to give you some examples. Okay, so we could very easily do a get min. We could have a min so far. We could very easily change it to work with get min. We could do get range. We could do all kinds of stuff to it. Okay? Now let's talk about mean. Not mean as in mean as in mean. Okay? Anyone take statistics yet? Come on, dudes. I will tell you that I clipped out of statistics. I had a teacher that was actually my calculus teacher and taught a lot of my programming classes. He's a genius when it comes to anything to do with math. He taught a weekend seminar. He says, if you come to my seminar from like 8 to noon, you will pass the test. This CLEP test. So I came to his seminar, and he basically said, don't ask why, just know this. So I went there for 4 hours, even fed us lunch, which was weird. Took the test on Monday and passed it. Got full credit for statistics. Don't ever need to take it again. I will tell you that was probably the worst mistake I ever made. Because I know what statistics is, but I don't really know it. You know what I mean? It's like I feel like I gypped myself. Like I know what mean, medium and mode is, but it's like I kind of missed out on that. So one of these days I'll take statistics again. I just feel like I gypped myself. And there's a lot of students nowadays who don't care. I don't want to learn nothing. I just want the piece of paper. Well, hopefully you're here to learn something. Okay, let's play with mean. Okay. So I'm going to define a new function called mean. Okay, mean is equal to the sum. We haven't played with that before. Okay. Pretty short little function here. Okay. I'm going to go back up here for a second. It says mean is the average. So to calculate the average, we really add them all up and divide by the number. That's exactly the way it works. Okay. So to use this, I could say mean a list. It'll take that list we had defined already. It would add up all the elements in it and then divide it by the number. And there's the average of our list. Okay? Let's make sure this is really working. Mean, I'm going to pass it 2, 4, 6. What should the average be?
4.
Should be 4. So it is working. Okay. What if I passed it 2, 4, 7? It shouldn't be 4 anymore. It should be a little bit above 4. There it is, 4.333. So it is working. So what it does is it takes the sum adds them all up, gets the sum, divides it by the length, and then we get the average. So, very quick and easy way to do it. Okay. Do we need to create a method for that? No. We could literally use the statement, sum, but it's easier that way. Our method's already made. Now, if I was you, like when I used to actually write programs that made me money, I used to always make a utilities file. Like in Python, you would call it utils.py. And anytime you had a really cool, simple method like this, you would add it to it. Then you always imported that. You know how we imported Turtle? I always imported utils in every program I wrote. Then I could call any method I ever made. So if we added mean to that file, then we never have to write it again. We can always just import it and use it. So pretty simple to do. Okay, let's continue on. Okay. All right, here's median. This is the second is median by locating the item that occurs in the exact middle. All right, he didn't write the method? I thought he wrote the method. He does here in a minute. Okay, but before we can find the median, we have to sort it. Okay? Because if again, we went through the room here and I asked, we wanted to find the middle grade, it'd be very hard if you weren't sorted. Because I could say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of you. So 1, 2, 3, 4, 5. So she's in the 5th position. So she's the middle grade. What's your name? Brittany? Okay. So she's the middle by seat position. But is she the middle grade in the class? She might be offended by that. She said, no, I have a higher grade than the average. I have 100 or whatever. Or she could be like, sweet, I had a 0. But now I have the middle grade. So, it wouldn't be a good idea to just go by seat position. Okay? Hopefully you don't have the 0. I don't know what you have. So. Okay, so let's talk about how this works. Okay? You see they have a list of numbers here. Okay? And it's basically the middle position. But to get it to work, you got to sort the darn thing. Okay? So I'm going to walk through what he does. We already have a list. I mean, you can type in the new list if you want. But you cannot. We're going to sort it. Sort, we actually mentioned it last time. But sort is a method that pertains to classes. Okay? So what it did is it took my list. Darn it, I should have saved it first. But oh well, my list is now sorted. So when I call sort, it literally reorganized my list. Because now when I type a list, you'll see the list is actually sorted. Okay? Everybody see that? Pretty quick and easy. Okay? Now I can actually find the length of it. See how many items are in it. Okay, I got 7 of them. Then I can actually divide it by 2. Bring that down. Integer division. I want to show you what happens if I don't do it that way. Everybody see the difference between those two statements? The first one was integer division. The second one was just regular division. Okay. Because if I wanted to find the, what are we working with? It's the median, I'm sorry. Okay. So if I wanted to find the median grade in this room, I can't say it's it's not the person between Cameron and Brittany. It's not that person. I really need to specify a person. So 3.5 is not really a good option for me. So I need to know a whole number. So in this case, it truncates it to 3. Okay. So, all right. So let's, and you'll see in his example here, we can do the same in ours. We can type a list 4, and it'll actually show you the 4th element, so on and so forth. Okay. So you've seen that before already. Okay. So now we know how to sort it. So there's his method. I don't want to type all these in because we'll be here all day. Let's just talk about what it does. Okay. So his median method creates a new list, which is actually the list that's been sliced with the the colon there. Okay. Then it sorts it. Then it finds the length of it. That percent sign. Remember we talked about the percent sign in like week 2? Modulus, exactly. You will use that in other classes. So we're trying to determine if it has an even number of items in it. And that's how you can use it. You can use the modulus for that. So, if it has an even length, then we calculate the right, and then the left, and then the overall median, okay? I mean, I'm not going to test you on statistical functions in Python. Just know it's pretty simple to do it, okay? Now, if it's the odd, it's a little bit easier to do, okay? All right. And so when he runs it, we're actually finding the median value. So our list, so we have 1, 2, 3, 4, 5, 6, 7 items. So shouldn't 26 be the median? Well, 26 would not be correct because that's not the middle grade or the middle number. So what they did is they copied the list and they sorted it, then actually determined it at that point. Okay? All right, let's continue on. Okay, mode is the data set the most frequently occurring value. Okay? In other words, what item is in the list more than any other item? And this is examples here. Obviously you can see that in the first grouping up here, where's my cursor? There it is. You'll see that 1 is in the list more than any other. Okay? But in the second one, you'll see that 1 and 5 are both the same. So the mode could actually have more than one value. In other words, what is the most frequently occurring number? Okay? Alright. Then they start talking about dictionaries. Dictionaries is where it gets a little confusing. Not a lot, but a little bit. Remember we talked about collections. We talked about sequential collections because that's what we've been working with, strings and lists. Well, not everything is sequential, hence dictionaries. Okay, and in the example he gives us here is so now we have it's not really a list, it's a dictionary. I don't know why they call it that, but we basically have one called ages. Actually, I'm gonna walk through this example so we can see exactly what it does. Ages equals David, 45, Brenda, 46. Alright, if I type ages, we have a key and a value there is what we really have. What we basically are saying is David is 45 and Brenda is 46. Okay? So you have an item like the name and then the value that goes along with it. Okay? Nothing overcomplicated yet, but there's a lot of things we can do with this. Okay? Let's continue on. Okay? So if I just type, trying to get it on the same screen. So if I just type ages, I get both of them. But what if I want to see David's age? Ages of David. David's 45. What if I did ages of Ken? There's no such item. Okay? And this is not covered yet, and we're not going to cover it yet, but whenever you write a program, you don't want this to happen. Because this is an error. Y'all agree that's an error? Kind of like we had an error a minute ago without the string. Can you imagine if this was a production and someone typed in something and it crashed? This is basically a program crashing is what happened. So we're going to talk about error handling later, but yeah, something you don't want to happen. Like last week when they ran out of iPhones, basically they killed the server. So the server basically said, oh, we're busy stocking the Apple store. What that was is that was their system basically saying, crap, the server's down. But rather than telling the user the server's down, it went to a generic error page. A lot of places, you ever go to a website and you type in something you're searching for? It comes up with, oops, can't find that, but maybe this page will help you instead. That's kind of what this is saying. Hey, Ken's not there. But it's just not doing as nice. Okay. So, what if I did ages Ken, shorter to type than Kelsey, equals 21. Obviously, I'm 21. You all agree with that. Okay. What it did is it actually took the listing we had, or the dictionary, and added Ken to it. So now if I just type ages, you'll see now it's no longer just David, it's David and Brenda and Ken. Okay. Pretty simple to do. And if I want to know how old Ken is, and it no longer crashes, now it actually tells me my age. Almost times 3. Okay.
What is the age of cameras?
Oh, that number's too low. It's like 12, I think. Okay. Alright, so you see we can very easily locate an item and output the result. We can add new ones to it. We can see how many's in it. I could say the length of ages. In other words, how many people are in my dictionary. We have 3 of them. Okay, easy enough there. Alright, so that we need the next file. 27. So we're on 137. We're almost out of time. Alright, with it we have what's called keys and values. So the keys would be the names. That's, Ken. The values would be the ages. Okay? You could also see the items. You could also get a specific item. And let's look at some examples of those. So if I was to go to my list right here and type ages dot keys, I think it needs parentheses, doesn't it? Yeah. Okay. Let me move this down. Okay. Bless you. So if I did ages keys, it returns the names, which are basically the things you could search for. Then you could return the ages as well.
What's in for you?
It's just saying it's the dictionary keys. Okay. Now, if I wanted to tell it list ages, list the keys. Now I'm already telling it, hey, it is a list, so you don't need to tell me, and it just does it without the dictionary keys. Okay. Now, if I want values, this time I want, rather than the keys, I want the values. They are ordered, so you can see which one's with which. I can also see the items. Okay, so lots of different things you could do with this. In the past, I have had students write address book programs. I don't know if I will do that in this class. I probably won't. You guys are saying, yes, thank God. But, yeah, so we'll see how that goes. You can get items, like they have alist.get for returning a specific item. If there are none, it says none. You can delete an item from it. It will delete the keys and the value for that item. So if I told it, just like they're doing down here with the delete David right there, if I was to say delete ages Ken, it would actually remove Ken from the list. Okay, easy enough there. Okay. And I could also go through the list using a for loop right here and print all the items. So for K and keys, and it was for all the names, print them. It'll print them in the list. Could all do the same thing for values. For, K and ages at values, it would print all the numbers. Maybe I want to see, it's kind of like, we're not really supposed to, like I can't, on my wall, I cannot post a listing of your grades. Because this new FERPA, and it might hurt somebody's feelings, so I can't do that. But I could actually just post a list of numbers. So what if our listing here wasn't ages, what it was test scores or final grades? What I could do is I could list just the numbers. But I'd have to make sure it's not alphabetical. That way, someone wouldn't freak out. So I could very easily print. Well, let me. Because here, if I actually said a list, it's ages. Dot values. I could see just the values. So actually, when I was in Tulsa, Dr. Schnoy would do that. He would actually always print the test scores on the door. But there, he had you pick a number. At the beginning of the semester, say, pick a 4-digit number. And you would tell him your number, and then you'd go there, and that your number would have a grade by it. That's how you got your test grades. So. And he was very quick. I mean, you take a test, he would go right back to his office and grade them all right there, which was kind of nice. But sometimes you would wish he had waited a few days, because you'd get that news, and then you got the depression going for a few days, that kind of stuff. So, all right, so let's continue on. Okay. You can actually have separate lists. We're not going to walk into that. They walk through completing the mode. I don't think I want to cover much in the rest. We're just going to barely talk about a couple of them. But mode, again, we could calculate, figure out which one's the most frequently used in the list. And obviously, mode can have more than one. So we might want to, as we find them, create a list of them. And you're not going to have to do this for a test or anything. So just so you know, they're there. You can look at them, okay? You can also do frequency distribution, especially when it comes to encryption. That is a very important aspect. So other than Cameron, what's the most popular letter in the English alphabet? Anybody?
Popular letter.
Most popular letter. E. It's actually E. You ever watch Wheel of Fortune? Does anyone remember? Well, most of you are too young. But in the past, they didn't give you the R, N, S, T, L, and E. They didn't give that to you. You actually had to pick that yourself. Now it's like, oh, we'll help you. We'll give you all the popular letters. Then you can just guess it. It's stupid. But yeah, the E is the most popular letter. And when using frequency analysis, you can decrypt text. You can do all kinds of stuff with it. But again, that's a whole other class. So we're not going to actually walk through it, but he does give you an example of doing that. He's going through the list and looking at what's the most popular item. I could very easily go through there and see what's the most popular grade in the class. Okay, like maybe somebody gives out too many hundreds or something like that. I don't have that problem usually. Sometimes I do. Not very frequent. Okay, so there's how his frequency table works. Okay, we're not going to do that. Okay. So he talks about doing without a table. You can actually do it with a list rather than a table. And he's doing it with a list. Very simple. And we're not going to walk through it. Sorry, I know you're all depressed. And you can even use Turtle to draw a chart. A little bar chart. So he gives you, I think he gives you that too. It's on the next page. Almost done here. I think there's a teeny tiny little bit left. So yeah, there it is. He actually gives you how to draw a bar chart of frequency analysis. So kind of cool. And we're not going to walk through it all because it's just a lot of typing, and you can very easily type this stuff on your own at home and get it to work. I hope some of you do this. When I was going to school, I literally typed in every single thing I saw in the book. I just wanted to know. When I learned MS-DOS way back when, I literally typed in every command. It said format C:, I typed format C:, and my hard drive died. I'm like, oh, probably shouldn't have done that. So I reinstalled DOS. So, hey, I learned how to do it. So wouldn't hurt you guys to walk through all this stuff. Okay? I think that's... Yeah, well, then they talk about standard deviation. This is the thing that always gets me. What they're talking about here is the grades. If I look at the average grade in here, then if all the grades in the class are very tight, say maybe the average is a 90, and pretty much all the grades were between an 88 and 92, that'd be considered a very small or standard deviation. But if they were spread out more, it's used a lot in statistics. Again, I don't teach statistics. That's the one that I really feel gypped on. But it says it's a measure of dispersion. that shows how far the grades are apart from each other. Okay, we're not going to do that one, but he does walk you through that as well. Okay, actually you need the math class for that because you need square root, which we've actually talked about before. But you could walk through that as well, and that's the end of this chapter. Okay. All right. Next week we're starting chapter 5. No program due at the moment. I know you're all depressed, but take the weekend off. But it wouldn't hurt you to walk through some of this stuff. Okay, let me stop this.